Alright, let's talk about voltage dividers. It's an important topic in electronic. So let's say you have a power source of 5 volts, some 5 volt coming in right here, and then you have some resistor right here, and another one at the bottom here. And we have the ground. This is kind of simplified version of the circuit, okay? So we have 5 volt coming in like that. And right here in the middle here, this is a voltage out. Let me check the color here. Maybe we go red, right? So we have, this is called the V out. This is a voltage. Let's say you have a 5 volt coming from some source, say from some sensor or whatever, and you want to power your, like you want to send that voltage to your ESP32. So let me see if I can draw some electronic here, go back to black, okay? So we have our electronic component here, and then we need to power this. This need 3, let's say we need 3.3 volts to power that little devices. How do you do that? We have 5 volts, and this device can take, the device can take the 5 volts you need it. So you have to devise the 5 volts. So it's in a range of 3.3 volts. So essentially, the V out here is the voltage drop across this resistor. Let's name this one R2 and this one is R1. So the current command, the voltage, some voltage drop here, right here, and then some is drop around here too. So we have R1 and R2. The formula we use is, let me change the color here, is the V out equal R2 over R1 plus R2 Vn. This Vn is the voltage here. This is the Vn. All right. This formula is derived from Ohm's law. If you understand Ohm's law, you know that Ohm's law states that voltage equal current time resistor. I don't know if you can see this. Time resistor. All right. Let's go ahead and prove this formula a little quickly. All right. So I'm going to open the little time here, maybe to decide. So we know the current traveling from here, like from the 5 volt to the bottom here is the same. So since those two resistors are on series, that means the total resistance equal R1 plus R2. Just like that, and V out is the voltage drop equals R2. All right. So let's use the V out here equal V2, voltage equals R2, and that equal current time resistance. Okay, the current is the same, so here is E1 and then E2. E1 equal E2. All right, the two is in series. Okay, and from here we know that the total resistance equal R1 plus R2. Okay, so the Vn, let's say Vn equal E time R total, resistance total, just like that. And from here we can now get the E, the current equal Vn over RT, which is equal Vn times R1 plus R2. Since the resistor total is R1 plus R1 plus R2. So here we get our V out. Maybe I should change the color here. Let me click this up. All right, let's see. Let's go maybe red. All right. So now we have a V out. So if you replace the I inside, we replace this one. We're gonna replace that. Let me change the color here. This is kind of a little bit handy. We're gonna replace this one inside this one. Yep, right here. So we get a V out equal I out to, no, we're gonna replace the I. So let me clean this up. Okay, right. This Apple pen is quite handy sometimes. Okay, so we have V out equal R2 times the current, which is Vn over R1 plus R2. And this is exactly the formula here, just a little bit rearranged. So if I kind of rearrange this a little bit, we'll get this R1 plus R2 equal Vn, because this is Vn. And then we get this formula. So with 5 volt, we can divide our V out so we can power the electronic we want to power it up. So let's say this one is the ESP32, ESP32. Or it can be the Raspberry Pi, doesn't matter. So with this formula, you can choose the resistor you want it to. Let's say in this case, we're going to choose our R2 to be like 10 kilo ohms or something. We know that the V out, we want like, let's say, okay, let's keep it simple. Let's say we want to divide this 5 volt voltage to like a half. So we get like a 2.5, yeah, 2.5 volts. So we can choose like a resistor with same values. So let's say we got a resistor for 10 kilo ohms. 10 kilo ohms, all right. So R1 equal R2. So we're going to translate this formula here. Let's change the color here. Let me go with, let's say blue, okay. We have V out. Let me turn this up. Okay. Let's say V out equal R2 over R1 plus R2 Vn. Okay. R1 equal R2. That implies that we have V out. This is a little bit for algebra. It's no big deal. R1 equal R2. That means we got 2 R2 Vn. And right here, we come back, we get V out equal, we can just cut this off, get half of a Vn. Okay, so V out equal, our Vn equal 5 volts, right? Let's say Vn equal 5 volts. So half of that, okay, this pen is really handy. So to 1 time a half of 5 volts, so we have a V out equal 2.5 volts. Let me change the color back here so we can circle this little thing. So we have your V out equal 2.5. So with a 5 volt, we can just cut the voltage to 2.5 using a 10 kilo ohm. It doesn't matter the resistor here because we just choose like the same resistor for the both of them. But sometimes this is a really simplified version when you just want to just power simple, like send your pin and all of that stuff. But it get really complicated when you gotta talk about like input impedance and all of that stuff. It get really complicated. So let me go ahead and then give some note here what you should use that for the divider for and what you shouldn't be using it for. So let's go, let's change the color here, okay. Okay, let's say use cases, okay, use cases. So you can use the voltage dividers for like for signal, okay, signal only, signal. Oh, sorry, that's not quite how you spell that things. Okay, this pen's really handy here. So use case. All right, you can use this for like signals, okay, signals. That's pretty good one. And not for, let's say, okay, let me change the color here. Not used for, okay, you can use this signal for something like for powering device. For powering, this is because the device you're trying to power, if it has some resistance to it. Let's say, let me redraw this one right here. Okay, All right, we have a resistor here, another one down here, and then we have a ground right here. Okay, we have the 5 volt coming in, and then we have a V out, just like that. Let's say your device you try to power with this output, it has some resistor to it. Let's say it have some dumb resistor into it. Okay, let me just clean this up. Let's say your load, that's what we call it. The load here have some resistor here. Okay, that's the V out. If your load has some resistor here, then this resistor will kind of affect this one. So we're gonna make this one, it's going to be put in parallel with this one, so the load also will be connected to ground, of course. So we have essentially another parallel resistor to this one. And if the resistor is somewhat a little bit like lower, then the current will take this path and then kind of going to affect the circuit. So that's I'm going to stop here because there's so much we can talk about it, but just remember that the voltage divided the V out is just the formula you can remember at the end of this one. If you want to think about this session, just remember this one, R2 Vn. Okay, that's the formula you use to kind of use a voltage divider. All right, that's a lot of stuff. Let's go ahead and build one.